So we've been talking about rationals and radicals, so naturally we're going to turn them into one problem. So this is the one the same.
Wow.
So notice I have rational exponents, but we can also rewrite this as a radical. So remember our formula where I have some nth roots of x to the n power? I can rewrite that as x to the m over n, to where my denominator is my nth root, and my numerator is the exponent. So if I wanted to, I can rewrite this as x to the fifth root of x cubed, like so. So the fifth root of x cubed. And we saw this week that if you want to get rid of a square root, you square it. Cube root, you cube it. So a fifth root, you would do what? Raise it to the fifth power. But let's just go ahead and just keep this as a fraction. I feel like that's going to make our life a little bit easier to solve. Now, before I solve this, I need to do what?
Make it equal to 0.
Not make, I mean, you could if you want to graph it, but my goal here is to get rid of this power. It's a fraction as 3 over 5.
Did you do that power?
I want to get that power to go away, meaning in math, turn it to 1. So how would you turn 3/5 into a 1?
Do the reciprocal.
The reciprocal, very good. Right? If I multiply this by 5 over 3, then this 5 cancels with that 5, and this 3 cancels with that 3, and it becomes a 1. So for today, how we're going to get rid of these rational exponents is to raise it to the reciprocal. Raise it to an exponent of the reciprocal. But before I do that, something else I need to do. That's going to make my problem a lot easier. Because if I flip it now, I'm going to raise this to 5/3, this to 5/3, and this to 5/3. That's a little too much. When I can make this a little bit easier, which is,
Make the 7.
yeah, move the 17 over. So isolate. So minus 17 on both sides. I get x to the 3/5 power equals 27. Now, to get rid of that exponent, I'm raising it to the power of what? 5 over 3. It's reciprocal. 5 over 3. That just gives me x on the left, and on the right, I have 27 to the 5/3 power. Let's use our calculator to help us figure out that math. 27, raise it to the 5/3, equals 243. So x equals 243. And let's test. Is 243 to the 3/5 plus 1744? So 243 to the 3/5 add 17 is in fact 44. So no extraneous solutions here. X equals 243. So that's what we're doing today. We need to multiply these exponents, not multiply, raise the exponent to its reciprocal. So we're multiplying an exponent by an exponent. That's going to give us a 1. So for this problem, I need to isolate my radical exponent, my rational exponent, by doing what first? Very good. I'm going to move this 5 over. So plus 5 on both sides. I get 2 times x minus 4/3 to the 2/3 equals 32. Now after that, divide by 2 on both sides. I get x minus 4 to the 2/3 equals 16. And then now, we got to get rid of that rational exponent. So I'm going to raise it to the power of 3 over 2. That's going to give me x minus 4 equals, well, what's 16 raised to 3 over 2? 16 raised to 3 over 2 is 64. Okay. And pause. Now, when we looked at x cubed equals 27, and I wanted to just go ahead and solve this by cube root all sides, x equals 3, I do not have to worry about a plus minus here, because a -1 cubed comes out as a -1, don't it? -1 times -1 is +1, times -1 is -1. So anything with an odd power or an odd root, you don't have to worry about plus minus, you don't have to worry about extraneous solutions. Now when that was a square roots, so x squared equals 4, and I want to solve this, I need to take the square root on both sides, and when I do, I have to account for the plus and the minus. X equals plus and minus 2 here. Because if I take a -1 and square it, what does it turn into? A +1, right? So the square here, anything plus comes out plus, anything minus also comes out positive. Same thing is going to happen here. This is going to turn into a plus 64 and a minus 64. Why? The reason is, what is my power? What is my exponent here? 2. I'm squaring this, right? I am taking the third root, but I'm also squaring this as well, which means anything in here that's a plus will come out positive. Anything in a minus will also come out positive. So down here, I need to account for that and account for the plus and the minus. I did not do that here because I'm working with odd power, right? This negative, if it's a negative, it's going to come out negative. A plus, it's going to come out plus. So before you begin each of these problems, you need to look and see, okay, what is my power? Is it even or odd? Odd? Okay, I don't have to worry about plus minus. Even, I'm squaring, I will have to worry about plus minus here. Because if I look at this 16 to the 3/2, I can rewrite it as square roots of 16 cubed. And remember, if we take the square root on both sides, we have to account for the plus and the minus. So that's why there's a plus and a minus here. Also, there's another way to tackle this problem, and you'll see it comes out as a quadratic. But I'm going to finish this first. So I have two problems here. I have an x minus 4 equals 64, and an x minus 4 equals a negative 64. To solve this, I just need to add 4 to both sides. And I get x equals 68 and negative 60. So x equals 68 and negative 60. Now, there's another way I can get rid of this fraction without having to multiply it by the reciprocal, and that is, instead, how do I get rid of this denominator? Well, I multiply the top by a 3/1, right? That'll cancel with that. That'll give me a 2/1, which means this is going to be left as a x minus 4 squared, which turns into a quadratic, which we know quadratics have two solutions. But we went ahead and multiplied reciprocal to get rid of all exponents, which is fine. So as you see with these problems, it's all about game planning. Looking at your exponent. Okay, don't have to worry about anything. Let me just do the reciprocal. Oh, I got an even power here. So I can either get rid of this denominator, work with that square, or do the reciprocal and worry about a plus minus at the end. So we look at this problem. Notice I have different fractions. What is my highest power? 2. So I'm going to have to worry about a plus minus, right? I'm going to have two solutions. How would you tackle this problem? What would you raise to both sides? That'll get rid of these fractions. Multiplying these fractions by what will get rid of the denominator?
Oh, the reciprocal.
3.
The reciprocal? So I could do 3/2. But there is a better option, which is multiply by 3, or raise to the power of 3. So let me do that here. Raise to the power of 3. Because what happens is, I get x minus 2 squared, because these 3's are cancel, equals 3 times 1/3 is just going to give me x. That would be the most simplified method, or the quickest method, or the easier method. Just raise each to the power of 3. All right. So we got rid of our rational exponents. Now we just have to solve this like normal. So I got a quadratic here. I need to distribute. So x times x, x squared. X times -2, -2x. -2 times x, -2x. -2 times 2, -2 is plus 4, equals x. What would you do after that?
Combine like terms.
Combine like terms. So x squared minus 4x plus 4 equals x. And then after that?
Bring the x from one side to the other.
Yep, let's set equal to 0. So move this x over. I get x squared minus 5x plus 4 equals 0. And then,
Just graph it.
yep, we have a quadratic. We could just graph. So I look at my graph here. My values are 1 and 4. So x equals 1 and 4. Then we got a test. So 1 minus 2 raised to 2/3. 1 minus 2 raised to 2/3 is 1. And then 1 to 1/3, 1 raised to, no, divided by, raised to 1/3 is also 1. So 1 works out. Now let's look at 4. So plug in 4 for x. Gives me that decimal. And then 4 for raised to the 1/3 power. 4 to the 1/3 gives me the same decimal. So 1 and 4, check out. They both work.